Today we're going to be working with probability of single events. This is an introduction to simple probability and the start of our fourth unit. So there's some vocabulary we need to know. We have outcomes, probability, the probability scale, and unbiased. First off, I know it's out of order, but probability is how likely something is to happen. What the chance of something either happening or not happening is. So probability is based on the number of outcomes and the number of events we're looking for. Outcomes are the possible results of an experiment. So everything that could happen or could not happen. The probability scale is what we use to basically give us the chances of probability. So it starts with 0 and then goes to 1. So anything in between there. It could be, like you see, 1/2. It could be 4 out of 7. It could be 0.86 because it could be a fraction or a decimal. As long as it's somewhere between 0 and 1, then that would give you a probability. To have a probability of 0 means it's never going to happen. It could never happen. There's not a chance. It's impossible. 1 means it has certain probability. It's going to happen every single time, or it's not going to happen every single time. And then unbiased means you get something that's in the middle. It's equally as likely to happen or to not happen. All outcomes are equal, and you have a 50-50 chance. So something that's unbiased would be like flipping a coin and getting either heads or tails, because there's only 2 options, and every time you flip a coin, you're going to get either heads or tails, even though tails never fails. Just a bit of advice there. Tails never fails. So we're going to start with our first example. And before we do that, we're going to look right here at this somewhat of a formula. It says P parentheses A equals the number of desired outcomes over the number of possible outcomes. So first off, this A means anything. It could be an event. It's something that we're looking for or we're not looking for. The probability that something happens. So, for example, I talked about flipping a coin. If I wanted to figure out the probability of landing on heads, I would write P parentheses heads. And that means I'm looking for the probability that I land on heads. Okay? So again, A means anything. And we take the number of what we're looking for and divide it by the number of all possible things that could happen. So if we look at our first example, I have a spinner with 8 sections that are all the same size, so it's split up evenly. There's 1 green, 3 yellow, and 4 blue. What's the probability of landing on green, blue, red, or yellow? So we're going to start with problem 1, green. The probability of landing on green. So we're looking for P of green. I'm just going to write G in this case. And if you look at our spinner, I only have 1 green slice. So that means I only have 1 desired outcome out of 8 total slices. So the probability of landing on green is 1 out of 8. In the second example, or the second problem, it's asking for the probability of blue. So P parentheses B for blue. And if I look, I have 4 blue slices. So that's going to be 4 out of the total 8. This can be reduced, though, to 1/2, which gets us a solution of equally likely. Because you have just as good a chance to land on blue as you do to land on anything else, because blue takes up half of the circle. Next, we're looking at the probability of landing on red, so P parentheses R. Well, if you look at the circle, there's no red. So how many reds do I have? None. Out of how many slices? 8. So this probability of red is going to be 0, which means it is impossible. It can't happen because we don't have any red. Lastly, yellow. So P of yellow. I have 3 yellow slices. So 3 out of 8. And that's basic probability. You're just calculating the chance you have to get what you want. In the next example, we're going to use the same picture, the same spinner, with the same amount of blues, greens, and yellows. Only this time, we're looking at the probability of not A. So the chance that something doesn't happen. So in this case, we're looking at example 1, or problem 1 in this example. It says, what's the probability of landing on not green? Well, if you follow this formula, you have P of A with a line over it. A with a line over it means not A, or not anything, okay? So if we're looking for the probability of not green, I would write P parentheses G, and I'd make sure to draw a line over it because that line means not. So the probability of not green. This is going to be, following the formula, 1 minus the probability of green. Now, on the previous example, we found that the probability of landing on green was 1 out of 8. So I'm just going to substitute that in there because P of G, or probability of green, is 1/8. So all I did was substitute that in. And if I want to change this 1 to a fraction so I can subtract, this would get me 8 over 8 minus 1 over 8, which is 7 over 8. And just to reiterate, I changed 1 to 8 over 8 because 8 divided by 8 is 1, so that I would be able to subtract the two fractions with the same denominator. And I ended up with 7 over 8. Now, this was kind of a lot of work. You don't have to do this. You really don't. What you need to do is realize what this is asking for. It's asking for not green. Okay? Look at the spinner. How many things are not green? This isn't green, that isn't green, that isn't green, that isn't green, that isn't green. Boom. All of those things are not green. Count up the slices. 1, 2, 3, 4, 5, 6, 7 slices that are not green. So 7 over 8. Right? P of not green. Okay? So we're going to look at number 2, which is asking for the probability of not blue or green. Remember, we have to have our line over it. That tells us not blue or green. So if I'm looking at not blue or green, that leaves me with these slices. How many slices are there? 1, 2, 3. So 3 out of the 8 slices are not blue or green. Get the idea? Same thing here. Probability of not yellow. Things that are not yellow. Here's 1, 2, 3, 4, 5 slices that are not yellow. So 5 out of the 8 slices. How many slices are not red? Well, 1, 2, 3, 4, 5, 6, 7, 8. All of them are not red. So the probability of not red is going to be 8 over 8, which is 1, which means this is a certain probability. And it's certain because there's no red. So not red, it's bound to happen. Okay. We're going to move on to looking at a dice. We have a standard 6-sided dice, and we're going to roll it one time. What can we expect to happen? Well, think about it. If you had a dice in your hand and you rolled it one time, what could you roll? You could roll a 1, a 2, 3, 4, a 5, or a 6. Those are your options. Okay? Not trying to trick you here, just literally what could you roll? How likely are you to roll a 3? Well, if you look at the options that you could roll, you notice that 3 only appears once. So the probability of rolling a 3, it's going to be 1 out of 6. The probability to not roll a 3, well, things that are not 3, there's 2 here and 3 here. 5 things are not 3. So 5 out of 6. Does this mean that you're more likely to roll, let's say, a 2 than you would be a 3? Well, no, because the probability of rolling a 2 is still 1 out of 6. Same with the probability of rolling a 4. But you're more likely to roll something other than the number that you're looking for. So if you were playing a game and you had to roll a 3, you're actually more likely to not roll a 3 because you're only stuck on that one number, and there's 5 other options that could happen. So that's what we're just trying to get at here. Let's look at this last page. So for our last example, we have a table. The table shows the number of boys and girls in 7th and 8th grade at a school. Okay, so this school, it's a 7th and 8th grade school, so it's a middle school, fine. And these are the number of kids in 7th grade and 8th grade, based on, are they a boy or a girl? So for this first part, a random student is chosen from 7th grade. What is the probability that the student is a girl? Okay, so we're going to reread that problem. A student is chosen from 7th grade. From 7th grade. So that means I can use these students because I'm only talking about 7th grade. And it asks, what's the probability that the student is a girl? So I'm looking at this number here. What's the chances that the student's a girl? Well, I'm looking at the entire 7th grade. In the entire 7th grade, I have 160 students and 86 girls. So the probability of finding a 7th grade girl is going to be 86 out of 160 because there's 160 kids in the 7th grade. Now, I'm not going to reduce this fraction, but I will divide 86 by 160, and that's going to get me a decimal of 0.53. So you have a 53% chance of choosing a girl out of the 7th grade if you're only looking at the 7th grade. Now we're going to look at this second example. A student is chosen at random. What is the probability that the student is an 8th grade boy? One more time. A student is chosen at random. What is the probability that the student is an 8th grade boy? So where are we getting our kids from? Are we getting our kids from the 8th grade? or are we just picking a random student? That first sentence is super important. A student is chosen at random. It doesn't say from where. So that means we're able to use all of these kids. And if we use all of these kids, I know that the entire school has 280 students if I add all those up. I want to pick an 8th grade boy out of those 280 students. So how many 8th grade boys do I have? Well, I have 64. Oop, pardon me. I have 56. I have 56 8th grade boys out of the entire school of 280 kids. And if I divide this, I'm going to get a decimal of 0.2, which is 20%. So if I took a kid out of this school, there's only a 20% chance that he's going to be a boy in the 8th grade. That's what that means. That's what this probability means. That there's a 20% chance that out of that school, if you pick a random kid, he's going to be an 8th grade boy. This has been the lesson on simple probability.